And we are recording. All right. Hello, everybody, and welcome to our next video on 2014, and we're doing questions number 3 and 4 today. These are both Calc inactive, and we're just continuing going down the list here. So if you haven't already, try these two problems on your own, and then check your answers with this video and anything you don't understand with this video, and we will be all set. All right. So, number 3 here. This is like one of the types we have. We're given a graph and we're asked a bunch of questions about it. So let's see what happens. It says the function f. All right, well, here, let me get started here. Let's see. Okay. So the function f, all right, is defined on the closed interval -5 to 4, and we see that on the graph above. And the graph of f consists of 3 line segments and is shown in the figure above, so we see that. And we're going to let g be this integral of f of t from -3, which is starting off right here, to any value x. Okay, so we're given the graph of f. Now, how does that relate to g? Let's go ahead and make that observation. We've seen this a bunch of times. If I were to take the derivative of g, that is equivalent to f of x by ftc part 1. And I think everybody's pretty good and familiar with that. And it's just remember, if I take the derivative of an integral, it gets rid of the integral, and we're left with just f, and that's by ftc part 1. Okay, so let's go ahead and make that observation. And remember, anytime it asks us to explain anything, we need to do it in terms of the graph of f given, which is g prime, which by ftc part 1. So anytime, I think a safe bet is anytime that you state this or any relationship like that, I would always state by ftc part 1. Okay. All right, A. It says find g of 3. All right, g of 3, that's pretty easy because we're given the g equation, so all I have to do is plug in 3 for x. So g of 3 equals the integral -3 to 3 of f of t dt. And since we're given the graph of f, we know that the integral from -3 to 3 is just the area underneath this curve, which with line segment is not too bad. Okay, so here we're starting off at -3 and we're going to +3, which is right here. Okay, so I need to find all these areas pretty much. This area and this area. Okay, so it looks like the area of 2 different triangles. Okay, so the area of this bigger triangle is positive one. It looks like if we just do the area base times height, it looks like the base is a length of 1, 2, 3, 4, 5, and the height is a height of 1, 2, 3, 4. So that first triangle is 5 times 4 divided by 2, which is just 10. And this bottom little piece one right here, this is a triangle. It's 1 by 2 there, so it's going to be 1 times -2 divided by 2, which is -1. Okay, so it's negative because it's below the x-axis. So we have one triangle that's area 10 and one triangle that's area -1. So this value is equal to 9. So g of 3 is equal to 9. Simple enough, right? Okay. Let's move on to B. All right, B says on what open intervals between -5 and 4 is the graph of g. All right, so we're talking about this the graph of g, and remember we're given the graph of the derivative. We're given g prime, and I want to know when g is both increasing and concave down, and we want to give a reason for your answer. All right, let's start with the reason. I always like to start with the reason. So we will first want to discuss when g is increasing, then we want to discuss when g is concave down, and that's both using the explanation of the graph given, f, which is g prime. Okay, so this is what I'm going to say. I'm going to explain both of these right here. First, I'm going to say g increases, okay, when g prime, which is equal to f, by ftc part 1. I don't know how strict they're going to be on that with this year, but it doesn't hurt to say. So g increases when g prime, which is equal to f by ftc part 1, is positive, right? Whenever the derivative is positive, it means my original function is increasing. Okay? And concave down when g prime, which is equal to f, I'm not going to state by FTC part 1 again, is decreasing. Okay? That's how you describe on the concavity based off of the derivative. Like if the derivative is decreasing, it means we're going to have a negative value for my second derivative and therefore being concave down. Okay? So we're looking on our graph right here of f, we're looking for when it's both positive and decreasing. That's when the original function is both increasing and concave down. So that happens right here and right here. Those are the two places where it's both positive value for the derivative and a decreasing function. Okay, so that's on the open interval. What is that? -5. Yeah, -5 to -3, and 0 to 2. Okay. Yeah, those are just definitions you have to know. Like if you're talking about g prime, that's how you describe increasing and decreasing and concave down and concave up. Okay. Not too bad. Move on. All right, number 3. Function f is number C. The function h is defined by g of x over 5x, and we want to find h prime of 3. All right, that's easy enough because we're given h and we just want to find the derivative with 3 plugged in. So let's start by finding the derivative. All right, so h prime of x is equal to, that looks like a quotient, so we're going to do the quotient rule. So low d high, and the derivative of high is just g prime of x. Low d high minus high, which is g of x. D low, derivative of 5x is 5. All over low low, or 5x squared, which is 25x squared. And all I gotta do is plug 3 into that. And before we plug 3 into that, I think it's helpful to go ahead and note what g prime of 3 is and what g of 3 is. Okay. Well, remember we found g of 3 in part A, and g of 3 was just 9. G prime of 3 is the same thing as f of 3, which is the graph given. So if I just go over to 3, that value is actually right here at -2. Okay. So we got g prime of 3 and g of 3. So if I do h prime of 3, that's equal to 5 times 3. G prime of 3 was -2. Minus g of 3 was 9 times 5. All over. And then 25 times 3 squared, which is just 9. Okay. And honestly, guys, this is calculation, so I think if you leave it this way, you should be fine. But just to kind of simplify it a little bit, that's -30 minus 45 over 225, which is equal to -75 over 225, or honestly, that simplifies down to -1/3. But I think if you left it at either any one of those 4 answers at the bottom row there, you should be fine. Okay. There you go. So that was part C. So I am praying, I really hope you do get a graph of f given, because these problems are pretty computational, and they're not too terrible as long as you've done enough practice, I think. Okay. And then lastly, let's do D. Okay. D says the function p, so we got a new function here, is defined by f of x squared minus x, and we want to find the slope of the line tangent to the graph of p at x equals -1. Now that may look confusing, especially the notation for p of x there, but just by definition, if you want to know the slope of a tangent line at a point, all you got to do is take the derivative and plug the point in. So if I'm given p of x, let's take the derivative of p of x and just plug in -1, and that's all it wants you to do. Okay, slope means derivative. Take the derivative, plug in the point. So let's take the derivative of p of x. So p prime of x is equal to, all right, Well, okay, so I gotta take the derivative of f of x squared minus x, and all that is simply just chain rule. So the derivative is gonna be f prime of x squared minus x, and then times the derivative of the inside, which is 2x minus 1. Okay, and then all I gotta do is just plug in -1 into that. So p prime of -1 equals f prime of, that's 1 minus -1, which is 2, so f prime of 2. And then if I plug -1 into this quantity, it becomes -3. -1 times 2 minus 1 is -3. Okay. And what is f prime of 2? Well, we're given the graph of f, so f prime of 2 is just the slope at 2. So it's the slope right here at the value 2. And because that's a linear equation, I can figure out that slope just by doing rise over run. And I did it by going down 4 over 2, and that's going to be a slope of -2. So f prime of 2, the slope at 2 of this graph, is equal to -2, and then times the -3, and you get 6. That is a 6. Again, f prime of 2 is just the derivative or the slope of the graph given. Okay. And yeah, that does it for number 3. I think this question was really doable. I think I was asking some good questions, but stuff we've practiced like numerous amounts of times. So really hoping that this is what you get. So anyway. All right, so that's question 3. Let's move on to question 4. Oh, yeah, well, here's the answers. So we can kind of break down the points here. A was just the answer. The fact that we got 9 by doing area underneath the curve. Here they stated that g prime of x is equal to f of x, so that's good. They didn't state by FTC part 1, but I definitely would just in case. And the answer with a reason. So we did the reason first, and we stated the answer. It's the same thing we stated, so that's good. C, so 2 points for finding the correct derivative in C, which we found. Okay, so that's good, which was this bad boy right here. And then just 1 point for finding the correct answer, which again, you could have stopped right here, and you would have been fine. Okay. And then D, 2 points for finding the correct derivative, which we did the chain rule. And then 1 point for plugging in the correct answer. So notice how f prime of 2 was equivalent to -2, and I just multiplied it out, got 6. Okay. All right. So again, that was question 3. Let's move on to question 4. Okay. This one is a chart problem. Again, another type of free response that we went over last week. And I'll be honest with you, first of all, this is a great problem. Love this problem to death, but there's some tricky parts to it. Just the wording can be a little confusing for some of these. But again, they're asking some great questions, so I'm glad that we have this one. All right, let's do A. It says train A runs back and forth on an east-west section of railroad track. So just picture maybe like, I don't know, you're going from like Charlotte to, I'm not good at geography here, Charlotte to east and west of Charlotte, okay? Maybe you're just going back and forth, left and right, okay. And it says train A's velocity measured in meters per minute is given by a differentiable function v a of t, where time t is measured in minutes. Selected values for velocity are given in the table above. So notice what we're given. We're not given its position, we're given the velocity, okay, and we're given the minutes. So at the given minutes, I know what the velocity is. So it looks like somewhere between 5 and 8, it's changing directions. It's going from like maybe east back to west at this point right here, if that makes sense, because we're changing velocities direction. Anyway, so part A says find the average acceleration of train A between 2 and 8. So don't get confused with average value. That is average acceleration, which acceleration is the rate of change of velocity. So all it's asking here, this is a fancy way of saying find the average rate of change of train A. Train A's velocity, I guess, which is we're given those values in the chart. So all we have to do is simply to do the average rate of change of the velocity or acceleration is equal to VA of 8 minus VA of 2 over 8 minus 2. which is equal to negative 120 minus 100 over 8 minus 2. And I know it's calc inactive, but I would probably simplify this down at least. Maybe, right? That's negative 220 over 6 or negative 110 over 3. And this is acceleration, so the units of measurement here are meters per minute squared. That's the acceleration's units of measurement there. Okay, so part A was just average rate of change. Nothing too bad there. Okay. Part B. Love this. It says, do the data in the table support the conclusion that train A's velocity is negative 100 meters per minute at some time t between 5 and 8, and give a reason for your answer? So if we're supporting some conclusion from a chart, it's either going to be Rolle's theorem, mean value theorem, intermediate value theorem. You have to choose from one of those three. And it's all dealing with your output here. You got to see what value they're given as the conclusion. You have to see which one that most appropriately fits with. I'm given velocity. I'm given meters per minute. Those are my outputs here. And I'm trying to decide if I have another output of negative 100. That's not a derivative. That's not a slope of my output. So I can go ahead and eliminate mean value theorem and Rolle's theorem. Okay? Because it's not asking me to find a derivative or a slope of these outputs. It's talking about an actual value of the velocity, an actual output from this chart. That is the intermediate value theorem. Okay, just to draw it on a chart here, if this is time and this is velocity, it's saying that, like, it's saying, hey, here at 5 and here at 8, I have a value of 40 right here, and a value of negative, wait, did I say that right? Yeah, negative 120 right here. So by the intermediate value theorem, there has to be at some point at which it crosses over negative 100 as a velocity. There has to be some t value between those 2 points. Okay, so that's intermediate value theorem. All right. So let's do a since then statement here. Okay. So we're going to say, and remember the requirements for intermediate value theorem. The only thing is it has to be continuous between the 2 points, and the 2 endpoints have to be between negative 100. And both of those are met. So I'm going to say since, and how can we determine that it's continuous? Well, it told me right here that it's differentiable. So I'm going to say since VA of t is differentiable and therefore continuous. That says continuous. So since the velocity is differentiable and therefore continuous, and VA of 8 is less than negative 100, which is less than VA of 5. So that value is between my endpoints. Okay, because it's continuous and my value is between those endpoints, then by IVT, there must, and I would spell out intermediate value theorem, there must exist a time t on the interval 2 to 8 such that VA of t is going to equal negative 100. So there's your since, there's your then by EVT. We stated the requirements, then we stated the conclusion. There must exist a time t on the interval 2 to 8 such that VA of t equals negative 100. So there you go, intermediate value theorem. There is a value intermediate between 40 and negative 120. All right. So that was B. Now, C's question, the wording can be just a touch confusing, so we're going to try our best to kind of break this down. It says at time equals 2. All right, let's really try to break down this question. At time equals 2, train A's position is 30 meters east of the origin station. Okay. And the train is moving to the east. Write an expression involving an integral that gives the position of train A in meters from the origin station at time equals 12. So to help us with this one, let's draw out a picture. I want you to see what's going on here. Okay, this we'll call origin station, literally because it's at the origin of my graph. And it's saying at time equals 2, okay, here is my train. My train is 300 meters east of origin station. So this is where so at time equals 2, here's train A. And it says that the train is moving east. Okay, cool. Now, from this, it wants me to figure out an expression that will tell me where I'm going to be at time equals 12. So time equals 12, I don't know where that's going to be at, but I have a reference point from the origin station. Okay, so how can I write that? We'll call this SA of t for the position of train A at any given time t. Okay. Well, all this is, we're given velocity. All we know is if we do an accumulation of time, which is an integral, from an initial position, we'll know any spot that I'm dealing with here. All this is simply an initial point, which we're given the initial point at time equals 2 is 300 meters from origin station. So I'm going to say SA of 2, which is nothing more than 300, plus the integral from 2, my initial starting point, to my endpoint 12. So all this is saying is take the initial spot I'm at 2 and add the accumulation of distance from time equals 2 to 12 of VA of t dt. And there you have it. That is an expression that gives that to us. Now, just to maybe simplify it down a little bit, that's going to be 300 plus the integral 2 to 12 of VA of t dt. Okay, so there's your answer. There is your integral expression that's going to tell me my position at time equals 12. It's where we initially start at 300 plus the accumulation distance of time, distance in respect to time from 2 to 12. Okay. Now, we're going to approximate this value. It says use a trapezoidal sum with 3 subintervals to indicated by the table to approximate the position at time equals 12. So what we're saying is it's like 3 subintervals. Well, there's 1, 2, 3, okay, in the chart above. So trapezoidal approximation says I'm going to do 300 plus this trapezoidal approximation. So SA of 12 is approximately equal to my trapezoidal approximation, which is going to be 300, the initial point, plus that trapezoidal approximation, which with 3 subintervals is 3 trapezoids. Okay. The first trapezoid is going to be 1/2 my height, which is from 2 to 5 is 3, times base 1, which is 100, plus base 2, which is 40. So that's my first trapezoid. Plus, my second trapezoid is 1/2. The height from 5 to 8 is 3, times base 1, 40, plus base 2, which is negative 120. And then plus my last trapezoid, which the distance from 8 to 12 is 4, so it's going to be 1/2, 4 is the height, times base 1, which is negative 120, plus base 2, which will be minus 150. Okay. And so that's going to tell me where an approximation of where I'm going to be at time equals 12, because I'm doing my initial position of 300 plus the accumulation of distance over time over those 10 minutes. Okay. It wanted me to approximate where I'm at. I'm going to See, I think you would be okay if you left it that way. Um, but I would probably, I try to simplify it as much as you can. That's a harder one. It's a time consuming. If you have time, I would simplify it. That's going to be 300 plus in the trapezoid. That's the values I got were 210 minus 120 minus 540, which is 300 minus 450, which the final answer is negative 150. So if you do the approximation, all the way out, it's negative 150. And what that means is because it's negative, that's in respect to origin town. That means it's negative, that's the other direction. So instead of being east of origin town, that's 150 meters west of origin town or origin station, whatever it was. Okay. So again, I mean, I think you might have been alright if you left it as this bottom line here, but if you had time to simplify it, I would definitely try to interpret it in context with origin station. Okay. So there you have it. There was C. Now let's move on to D. And then lastly, D. When I first read D, it sounded confusing, but again, drawing a picture is really going to help here. It says a second train B travels north from origin station. So I drew this out again. It says it's traveling north, so it's somewhere up here. If this is origin station, that's my origin, then train B is somewhere up here. It says travel north from origin station. At time t, the velocity of train B is given by this equation. So let's keep that in mind. And at time equals 2, the train is 400 meters north of the station. So at time equals 2, I'm 400 meters north of origin station. And we're going to find the rate in meters per minute at which the distance between train A and B is changing at time equals 2. Okay. So it's all having to do with time equals 2. Let's keep that in mind. Well, from C, I know that at time equals 2, my train's position is 300 meters east of origin station. So that's like right here. Okay? So I got that B is 400 meters north and A is 300 meters east of origin station at time equals 2. And I want to know the rate at which their distance is changing. Well, we have seen this before. We know how to talk about the distance between A and B. This is nothing more than Pythagorean triangle. This is nothing more than Pythagorean identity, okay, or Pythagorean theorem. Okay, that's how you discuss this distance right here. It's wanting to know the rate at which this line right here is changing. We've done this way back in AB with rates of change. So we'll call this 400 our y position. We'll call this 300 our x position, and we'll call the distance between them our z position. Okay, and if it wants to know the rate at which z is changing, which is dz over dt, that's what it wants to know. Okay. Well, so we need to have every other value in order to find that. Like we know what z is equal to by Pythagorean identity. This is just 500 because it's 400 squared plus 300 squared equals z squared, and that's how we got 500. Now the only other things I need to know is what dx over dt is and what dy over dt is. And if I know those values, then I can solve for dz over dt no problem. Okay. Well, dx over dt is the rate at which train A's position is moving, which at time equals 2, if you notice, that velocity is given in the chart. It's 100. This is 100 meters per minute. It's changing that much at time equals 2 from our chart. Now, how do I figure out the one for y? Well, I know the velocity of y, which is given right here. So all you have to simply do is plug in for y dy over dt is equal to whatever VB of 2 is, and when you plug that into this equation, I got that was equal to 125. Okay, so now we have everything that we need to know. Okay, so what I'm going to do is use remember with related rates, we got to come up with a formula that relates all these together, and that's nothing more than our Pythagorean theorem. So we're going to say x squared plus y squared equals z squared, and that's 2x dx over dt plus 2y dy over dt is equal to 2z dz over dt, and remember dz over dt is what I'm solving for. So remember the 2's can cancel out in these types of problems. So now I just plug in all the other values and I solve. So when I did this, do it over here, I plugged in x, which was 300, dx over dt was 100, plus y was 400, and dy over dt was 125, which equals z, which is a 500, times the quantity I'm looking for, dz over dt. So whenever I solved this out, guys, originally I did dz over dt equals, and I didn't really simplify it. I did 3 times 100 is 30,000. I did 30,000 plus, and originally I didn't do 400 times 125, but that's going to be 50,000 if you do it out. And I divided that by 500, and that's your final answer. But the answer key actually simplified this down all the way to 160, and that's going to be meters per minute. Okay, so the problem wasn't hard once we knew how to set it up. Okay, it's just a confusing wording. It was a lot of stuff, but dude, draw a picture. That really helped me, is to draw a picture, and then hopefully we'll be able to kind of see what it's asking. Related, distance between A and B. Oh, okay, that's Pythagorean theorem. I see that it's a triangle. That's the hypotenuse is changing. So the answer was 160 meters per minute. That's the rate at which the distance is changing. Okay. Well, there you have it. That was part D. So here is our answer key. We found the average acceleration with the correct units in A. We had our, it wanted us to clarify in part B one of the requirements to do IVT, and then a conclusion using IVT, which we did. That's our since then statement. We came up with our position expression. Okay. We came up with our trapezoidal sum, which was negative 450. And then the position at time equals 12, which was negative 150. And again, if you got that unsimplified, I think you would have been fine. And then lastly, the fact that we did implicit differentiation of the Pythagorean theorem, and that was 2 points. So the fact that we knew to do this right here, and then just 1 point for taking it all the way to the answer, which I think if you left it as like 80,000 over 500, or really just an unsimplified version, you should have been fine. But I would have put in meters per minute. Okay. All right, guys, and that does it for numbers 3 and 4 for 2014. Tomorrow we'll do questions 5 and 6 for 2014, and then we'll move on to the next day to 2015, numbers 1 and 2. Okay, so good luck, and let me know if you have any questions.